Sound is a form of energy. Like it produces by a vibrating body. Okay. Just like solar energy, light energy, heat energy, sound is also a form of energy. And it produces like, by a vibrating body. Let us try to understand. Like here in this chapter, we will be learning source of sound, what is the mechanism of our voice box, and also how, on which sound quality, loudness, that pitch. These are some of the characteristics about sound we will be learning, and how it propagates, how it travels in solids, liquids, and gases. So sound propagation, sound properties, speed of sound related and echo related, and sonar. There's a concept called sonar. Based on that, we'll be learning all those concepts in this chapter. What are the different types of sounds also we'll be learning. Sound, like every day we hear sounds from various sources like humans, birds, bells, machines, vehicles, televisions, radios, etc. Sound is a form of energy which produces a sensation of hearing in our eyes. Okay. Produces a sensation of hearing in our eyes. There are also other forms of energy like mechanical, heat energy, light energy, solar energy, wind energy. Okay. This is also one of the form of energy. Production of sound, if we talk about, like a tuning fork and a set it vibrating. Take a tuning fork and set it vibrating by striking a prong on a rubber pad and bring it to near your ear. Then what happens? You will listen some sound. See what this is what tuning fork. Okay. This is what the tuning fork, and it is used by ENT specialists to test whether your ear is working or whether you are able to hear properly or not. They will check it with this instrument. They will make it to vibrate and they will just keep the behind of your ear. They'll keep in contact. They will keep it this in contact with our ear nerves. Okay, eardrum, ear nerves, some nerves. Then they will test whether you are able to listen properly or not. So whenever you make it to vibrate this particular tuning fork, the sound is generated. The sound is produced. Okay. So that vibrating body is the source. Vibrating body is the source of sound. Okay. So what you do now, you can also keep your hand on the throat and you speak something, you will observe that your voice box is vibrating. Your vocal cords are vibrating. You can check it now. Yeah, you have checked it. So what you have observed? What you have observed, Supajit?
Sir, the voice box is vibrating.
Yes, very good. So whenever a so with this activity we can understand that whenever there is a vibrating body, there is a sound produced. Okay. The next step, another activity: fill the water in a beaker or a glass up to the brim. Gently touch the water surface with one of the prongs of a vibrating tuning fork. Next, dip the prongs of the vibrating tuning fork in water. Observe that. Observe what happens in both the cases. Gently touch the water surface with one of the prongs. Next, to dip the prongs of the vibrating tuning fork in water. And let us come to this part again. So if you fill water and if you bring the vibrating tuning fork near to it, then what will happen? Simply touch the water surface. What happens? The sound waves travel from the tuning fork to the water surface. Tuning fork to the water surface, and there you can see the sound travels in the sound no, in the water, and there are waves, certain waves form in the water medium. Okay, and do you know like there is one interesting thing I have already told previous batch. Yeah, you watch this video and try to understand how the Indian science technology has been used, like in the pillars, musical pillars of Hampi. Hampi is in Hampi, located in Karnataka. These are actually musical pillars. Okay. The interesting thing here is, so if you make certain sound, and you bring some water near to it, then there are certain patterns formed. There are certain patterns formed. Okay. That patterns formed in the water is printed on that particular pillar. That is what the beauty. That is what the greatness of our ancient Indian scientists. So once again, I repeat: there is a musical pillar temple located in Hampi, Karnataka. So what happens, So when you make some kind of sound, like when you make it to vibrate these pillars, sudden sound is produced, and certain sound results in certain kind of wave patterns. Okay, certain sounds results in certain kind of wave patterns. That wave patterns, whatever it produces, like that can be seen when you bring water near to the pillar, and that particular wave pattern is printed on that pillar. So that is the beauty, and that is the depth of acoustic knowledge in ancient India. Okay. Did you understand it? Okay, fine. Good. And in the same Hampi only there is a one more temple. You can see inverted image of the tower, temple tower. We say Gopuram, temple tower, inverted image of Gopuram. Also, like optics, is also they have used, and here sound technology, acoustics technology have used. Hampi, once you go and visit, there are many historical and scientific temples. That's what. So whenever you bring any vibrating tuning fork near to the water, then water forms certain patterns and it propagates in the form of waves. So that is what we observe actually. Okay. And when you completely dip also, like total vibrations will be passed and the patterns will form in the water. So from the above activities, we can conclude that in the above activities we have produced sound by striking the tuning fork. We can also produce sound by plucking, scratching, rubbing, blowing, or shaking different objects. The main thing is it has to vibrate. Okay. As per the above activities, what do we do to the objects? We set the objects vibrating and produce sound. Vibration means it is a kind of rapid motion, to and fro motion. The sound of the human voice is produced due to the vibration of the vocal cord. When a bird flaps its wings, do you hear any sound? Think how the buzzing sound accompanying a beep is produced. So when the birds are flaps when they flaps their wings, na, then also air column nearby it is vibrating. So sound is produced. A stretched rubber band, when it is plucked, it vibrates and it makes the sound, produces the sound. If you have never done this, please do this. So basically, the summary of this activities is vibrating body produces sound. Okay. And after production of sound, what happens? How it travels? That is what propagation of sound. Propagation means traveling. How it travels in different media, in solids, liquids, gases. Okay. So sound. So when we go before going for this, let us try to talk about some waves, different kinds of waves that are possible. And let us try to understand this different types of waves. Transverse waves, longitudinal waves. Okay. Transverse waves means particle motion and wave motion are perpendicular. What do you mean by particle? What do you mean by wave? There are two different kinds of waves. One is transverse waves and other is longitudinal waves. Transverse waves definition is particle motion and wave motion both are perpendicular. You can see in the diagram. Okay. Like, so you see in the diagram of transverse wave, that particle is there, it moves up and down, up and down. That blue colored one, up and down. But wave, you see, wave is moving towards right direction. Wave is moving towards right direction. Particle is vibrating up and down. Okay. So particle moves up, down, up, down, up, down at every point of the wave. But wave is traveling rightwards. You can see in the diagram. So if you observe, the particle or that particular atom or that particular molecule is moving up and down, but the wave is propagating towards right. So you can observe that both particle and wave are perpendicular in this kind of wave, transverse wave. The next, longitudinal wave. Longitudinal wave is nothing but particle and wave both are parallel. Particle motion and wave motion are parallel. You see in the diagram, particle movement is left to right. Wave is also moving from left to right. Okay. So red one, you see, particle is moving either left to right, left and right, oscillating it is, or vibrating. Okay. And wave is also moving in the right direction. That kind of wave is called as longitudinal waves. Examples for transverse wave is all electromagnetic radiation, like light waves, light radiation, IR radiation, UV radiation, X-rays, radio waves, microwaves, water waves, all are transverse waves. And longitudinal waves example is sound waves. So when we are talking actually, so how it is reaching to other person is in the form of longitudinal wave. So what is happening when we are talking near to the our mouth, there is a air column. That particular air column gets vibrating, and it is transferring the energy to surrounding air column. And again, first to second, first to second, second to third, third to fourth air column, and finally it reaches the other person ear. So that kind of vibrations of the air column and the movement of the sound, both are in the same direction. So that is why sound waves are considered as longitudinal waves. I repeat, when we are talking near to our mouth, the air column is vibrating. Air molecules, air particles, air atoms, whatever atoms are there in a column, it is vibrating, and it is transferring the energy to surrounding column, and it is transferring the energy to surrounding column. So like that, so on. There are some innumerable sound air columns are there, and they transfer the energy, vibrational energy, and thereby sound is traveled from my mouth to your ear. And if you observe that, particle is also vibrating along horizontally, motion of the movement of the sound wave is also along horizontally. both are in the same direction. So that's why sound waves are longitudinal waves. And if you see in water waves, water you see, if you want to understand particle and wave motion are perpendicular, like you leave a wooden block. You leave a wooden block on the surface of the water. Okay. Then what happens? Wooden block will move up and down. Wooden block will move up and down whenever there are waterways, and wave is propagating towards right or left. So with that we can understand, like, particle is vibrating up and down, and wave is moving right or left. Both are perpendicular. In the case of longitudinal waves, both are parallel. Prachita's doubt is, in loudspeaker, the sound travels in longitudinal waves. Yes, loudspeaker means sound. It is a sound. So sound always travel in longitudinal waves only, in the form of longitudinal waves only, Prachita. In the loudspeaker, or whenever, if I am speaking, in your home also you speak. Okay, in your home also you will be speaking. So wherever it is, the sound travels in the form of longitudinal waves. Okay, and it travels in the form of longitudinal waves. Okay. Now transverse waves are also called as non-mechanical waves, except some water waves. Okay. This is X-rays, UV rays, IR rays, all are non-mechanical waves. Water waves are mechanical waves. Okay. Then they do not require any medium, IR rays, UV rays, X-rays, radio waves, light rays. Okay. They are called as non-mechanical waves. And sound waves are called as mechanical waves because they require medium to propagate. They require medium to propagate. And now coming to the fourth point, associated with this transverse wave, in the transverse wave, there is a crest and there is a trough. They are associated with crest and trough. You can see in the diagram, this is a crest, maximum point in the positive side, trough, maximum point in the negative side. Okay, trough, crest and troughs. Like there are ups and downs. These ups and downs are called as crest and troughs for the transverse waves. And for the longitudinal waves, like we say, compressions and rarefactions. Compressions and rarefactions. Okay. So compression. So I already said, vibrating body produces sound. So whenever air column is propagating or traveling or moving, the sound is moving in the air column, then air column also gets vibrated. Air column also gets vibrated. So that air column, all the air column, surrounding air column is very close. When there is a very close, like, see, at some particular point, vibration means what? From the mean position, it may go to some extreme position, then again come to mean position, then again extreme position. So when 2-3 layers are meeting together, they are at the extreme position, and 2-3 layers are vibrating, then all the pressure, air molecules are at one particular point, and that their pressure is high, and that particular region we call it as high pressure region, or compression region. And again they will go to another extreme point, they will come to again, like they are vibrating. The air column is vibrating around the mean position. Okay, so So since they are vibrating at some particular vibrations, they are at closer, very closer. That when they are closer, that is called considered as compression region, and when they are far away, that is called as rarefaction region. You can see in the diagram. So low pressure region, rarefaction; high pressure region, compression. That is the definition for rarefaction, compression. Some of the points like wavelength, the distance between the two successive crests or troughs is called wavelength. Okay, two successive I said. So successive means, so this is one of the crust and it is one of the crust. So crust to crust distance. Successive means just after the other, one after the other. And trough, this is one of the trough and it is one of the trough. Trough to trough distance, we call it as wavelength. Okay, crust to crust or trough to trough distance, we call it as wavelength. And in the case of longitudinal wave, we define wavelength as the separation between two successive compressions or two successive rarefactions is called wavelength. Okay. And units, meter and centimeter. Okay. Wavelength, length, it is a length. SI unit is meter, CGS unit centimeter. And in the case of like these are all actually terminology associated with waves we are learning. Okay. So there is one more term called frequency. Frequency means number of oscillations or number of waves or number of cycles in a second is called frequency. Okay. So same definition only here also in the case of longitudinal wave also. But the longitudinal wave is a vibration related, so that's why we specifically speak number of vibrations in a second is called frequency. Number of waves, number of oscillations, number of cycles in a second, whatever you take the definition, is called frequency, and its units are hertz. Hertz or per second. And speed, wavelength and frequency relation. Speed is equal to wavelength into frequency. Speed of a wave relation. In the case of transverse wave, speed is equal to wavelength into frequency. And in the case of longitudinal wave, speed is equal to 2 into distance by time. So this formula, especially we use it in the case of echo. Okay. In the case of sonar, in the case of echoes, speed of a sound wave, like the sound has to go some distance d and it will come back in the reflection of sound. Whenever the sound gets an obstacle in its path, it gets reflected back. So since it is traveling up journey d, down journey d, so that's why we take 2d by time. Speed is equal to 2 into distance by time. Based on this, you may have to solve some numerical. Okay. Speed is equal to 2 into distance by time. In the case of like reflection of sound, we can say. When the sound is reflecting back, then up journey is d, down journey is also d. So normal formula is speed is distance by time. But in the case of reflection, if you consider reflection of sound, speed of sound is 2 into distance by time. Okay.